Hello again! There are multiple ways we can import text files into Python, and in this video, we are going to discuss two of them. In particular, we'll be going over loadtxt and genfromtxt, which both provide great utility when we're dealing with CSV files. Right. First of all, both functions are part of the NumPy package, so make sure to import the module into your Python notebook. In case you need a hint, to do that, we type in import NumPy. Convention dictates we use the abbreviated notion, so we add as np before executing the code cell. Next up, let's quickly go over the names of these two methods and what they tell us. Loadtxt suggests we are loading the values. Intuitively, the word load implies that the data is ready to be directly imported and used. In contrast, the name of the other function, genfromtxt, is short for generate from text. The generate part indicates that the function creates the dataset from the text file. Unlike loading, generating requires constructing the array as we go through the text file. This allows us to only take certain rows or columns as well as split the input into multiple variables. This distinction explains why loadtxt is faster, whilst genfromtxt has more flexibility. Understanding a concept theoretically is a great thing, but knowledge is best retained through practice. So let's jump back into Jupyter and compare these methods with some coding. We'll start by defining a variable to store the dataset. The original file contains numeric details about a lending company, so we'll go with a name that clearly shows that. Lending company data, numeric. We already mentioned we'll be comparing the two functions, so let's add an _1 at the end to designate this will be the first of the two variables we'll use. Of course, these are our own naming conventions, and you can name your variable whatever you like. However, sticking to a specific set of rules is always a good idea. Next, we set it equal to np.loadtxt. The np part signals to Python that we'll be relying on a function from the NumPy package we imported earlier. Then, within the parentheses, in quotation marks, we enter the name of the text file we want to import. This includes its extension. So, since in our case we're using a CSV file called lending company numeric data, we have to write lending-company-numeric-data.csv. Typically, you'd have the file stored in the same directory or folder as your Python notebook. Therefore, you can go ahead and define the delimiter. However, if that's not the case, you'd have to specify the entire path leading to the file you want to import. Since backlashes are often reserved for special characters like new lines or tabs, we rely on forward slashes or double backslashes. If you need any help defining the full path, check out our FAQ file for an extended explanation on how to do this. As we said earlier, we define the delimiter next. In case you need a refresher, delimiters are predefined symbols like commas and semicolons, which are used to define distinct fields in text files, like cells in a row or rows in a table. As you know, a very common approach is to store large datasets in text files this way because they take up way less space than spreadsheet files or similar alternatives. The delimiter for this particular file is a comma, so we type delimiter equals and then comma between single quotes. Generally, big and important datasets come with a brief summary explaining these specifics. However, if you don't know what the delimiter is, you can always open the file in a text editor like Sublime or Notepad++ and check it manually. Okay, to see the result of our work, we can call the variable we just defined in the next row by writing its name. However, you can only do so in Jupyter. If you're using an alternative platform like Spider, simply use the print function here. After running the cell, we see that we've successfully imported the data, which contains 6 columns of numeric values. The ... displayed after the third row indicates that there are more rows with data between the first 3 and last 3 rows of the dataset we see on the screen right now. However, our current focus is on importing the data, so our job here is done. All right. Next up, let's see how the generateFromText function works. Since the two functions have similar syntax, we can use the code we just wrote as a template and paste it in the next cell. The first change we want to make is to switch the name of the variable from lending company data numeric 1 to lending company data numeric 2. We're comparing the two functions, so saving the outputs in different variables is essential. Also, make sure to change the name on the next line, where we display the values. Then, we change the name of the function from loadtxt to generateFromText. Since we're importing the same file, we don't need to change its name or delimiter. So, we're ready to run the cell. We see what appears to be the exact same output. However, we can't make that claim based on 6 rows of data. Instead, we can call the np_array_equal function to check if the two datasets are identical. In the parentheses, we simply write the names of the two arrays, separated by a comma, and we're good to go. The function returns true, meaning loadtxt and generateFromText resulted in identical datasets. Knowing this, why does it matter which one we use? Well, the loadtxt is the faster of the two, but it breaks when we feed it incomplete or ill-formatted datasets. On the other hand, generateFromText is slightly slower, but can handle missing values. However, instead of taking what we say at face value, allow us to show you. Let's import a text file with missing values in it. For the sake of this exercise, we've provided you with an incomplete version of the same dataset titled Lending Company Numeric Data NaN. NaN stands for not a number and refers to missing values within a NumPy array. Right. We can once again paste the code we used for loadtxt earlier and make the necessary adjustments. Just like last time, we start by altering the name of the variable we're using to store the dataset. In this case, we can substitute the 1 for NaN. Of course, we can continue the pattern we set earlier and call it lending company data numeric 3. But using NaN is more descriptive, and that's what we should be aiming for. Next, we need to change the name of the file. As already mentioned, we only need to add -NaN before the extension, and we're set. We see that the NaN file uses a different delimiter, a semicolon. We can manually check this by opening the file in Sublime or Notepad++. Hence, we need to alter the delimiter value as well. Okay, once we've run the cell, we see that the loadtxt function results in an error as expected. If we scroll to the bottom of the error message, we'll read the message, could not convert string to float. Without going into too much detail, this means that Python encounters a symbol when it expects a number. Thus, if missing values in the text file are expressed with an empty space, this causes the function to output an error. And yes, the empty space still occupies an area in the text, so it does count as a symbol. Now, we can fix this issue in one of two ways. The first one requires switching over to the generateFromText method. Since our initial attempt did not compute, we haven't stored any values yet. So we don't need to change the name of our variable. We only alter the name of the function to generateFromText. We see that most of the output is similar to what we had before, 6 columns of data with more than 6 rows. However, in column 1, 3 lines from the bottom, we see the letters NaN. As we mentioned a little earlier, this stands for not a number. Therefore, it's NumPy's way of letting us know there was no numeric value in that position. We see that generateFromText handles missing data well. In practice, we often deal with incomplete or ill-formatted data, which is why generateFromText is preferred when dealing with data we haven't created ourselves. To showcase the other way to resolve this issue, we need to first revert to the loadtxt function. The solution requires telling Python to import everything as symbols instead of numbers. We do this by specifying the data types as NumPy strings, as we type dtype equals np.str. We see that all the values now have single quotes around them. That is because they are saved as plain text rather than numbers. This distinction is very important. It means that we can't just add them up or conduct other mathematical operations when we have strings. Therefore, we can use the second way of importing this dataset only if we want to observe the data values that have been stored in it. And we don't need to execute any mathematical operations. Should we need to do computations? Then we must use the first way to import the data, with genfromtxt. That's why it's crucial to make sure we import our data in the most appropriate type, according to the operations we intend to apply on it. All right. Next time, we'll discuss how to partially clean our dataset right as we're importing it. Thanks for watching.